Good afternoon and welcome to today's STS-135 mission status briefing. All the details of the one and only spacewalk of this mission. With us today we have Chris Edelin, who is the lead space station flight director for this mission. Glenda Brown, who is the lead spacewalk officer or EVA officer for the flight. And Ben Reed, who is the Satellite Servicing Capabilities Office Deputy Project Manager associated with the robotic refueling mission. We'll start off with opening comments from all three of them, and then we'll move on to your questions. Chris?
Thank you, Kelly. And thank you all for coming today. I'm very pleased to report that the one and only EVA planned for STS-135 was a great success today. The crew completed all of their planned activities, including return of the failed pump module to the shuttle's payload bay in order to bring it back to Earth, transfer of the robotics refueling module to the space station for future technology demonstration, as well as several other tasks that were on our objectives list. And the crew completed the EVA within 1 minute of the planned time, which should give you some indication of how right on target they were all day, and what a good job that the team on the ground did planning this EVA. And just to give you a little bit of historical background, this EVA was not originally part of the mission plan. When the STS-135 was baselined about 9 months ago, the station program, soon after the flight was baselined, identified a high priority objective to bring back the failed pump module, so they added the EVA to this flight. And the pump module on the station is the one that failed last summer. This pumps ammonia through the coolant loops on the outside of the station, sort of like the fluid in your radiator of your car that cools your engine. So without the pump module, the electronics inside of space station cannot be cooled off. So we have two that run on space station all the time. Again, this one that we just returned to the payload bay failed last summer, and we're bringing it back to Earth in order to determine what happened with it, what caused it to fail, and that's very important for the space station program to have an understanding of what kind of lifetime to expect with the pump modules that are currently on orbit. So that went very well. As I mentioned, we also installed a new technology demonstrator, the robotic refueling mission. Mr. Reed will be telling you more about that in a few minutes. The crew also installed a materials exposure experiment called ORMATE, which stands for Optical Reflective Materials Experiment. It'll study the effects of space on various high-tech materials. They also cleared out a wire that was interfering with a robotics grapple fixture, a payload data grapple fixture, or PDGF, on the FGB module. And that robotics grapple fixture is not operational yet, but we've gotten one step closer by clearing out this a ground wire, a small wire that was blocking access to one of the data and power latches inside that fixture. The crew also installed a thermal cover over our permanent mating adapter number 3, which is on the port side of the station attached to the Node 3 Tranquility module. This is a side-facing hatch, and it has a pressure equalization valve that when it's exposed to sunlight, it gets very warm, and the continuous thermal cycling on this valve is causing its seal to degrade over time. So this was, again, a high-priority objective for the space station program, to get a thermal cover over this hatch, and we've already seen from the data that the temperatures are stabilizing at a nice, comfortable level. So we'll be confident that this seal will last through the life of the station, through past 2020, and not cause a potential leak. So again, the history of this flight, when we added this EVA, there were lots of challenges. We had a small shuttle crew of 4, so we knew that putting this EVA on the shuttle crew's back would lead to excessively high training load. So we came up with the idea of putting the EVA on the station crew, and we took advantage of the fact that our 2 EVA astronauts, Mike Fossum and Ron Guerin, had already performed 3 EVAs before on a previous shuttle flight. So we took advantage of that synergy, and they jumped right in with their training. We trained this several times in the weightless swimming, the weightless simulator here, which is essentially a huge swimming pool, the neutral buoyancy lab. And one of the challenges was that because Mike and Ron were flying up to space station on Soyuz vehicles and not the Shuttle Atlantis, they would arrive in place several months before they'd execute the EVA. So that basically compressed the entire training flow for Mike and Ron. And so the last time they were in the pool together was back in February. So we, with the help of the ground team and our great EVA team here, represented by Glenda, they provided an excellent training plan for Mike and Ron on orbit. They've been preparing for the past several weeks, doing a suit fit check, self-study, reviewing the checklist, and they've conducted several conferences with our EVA team here in Houston to make sure they were ready. And you can really tell how smoothly things went today, how well prepared they were, and I just couldn't be happier with the performance of the team and the crew. Just to fill you in a little bit on the overall status of Space Station, today, again, the focus was on the EVA. Most of the crew was involved directly with the EVA support. Our shuttle crew, even though they didn't go out the door and perform the EVA, they were still key members. Chris Ferguson, our shuttle commander, was in charge of prepping the EVA suits and helping Mike and Ron into their suits both before and after the EVA. Rex Walheim was our spacewalk choreographer. He was on the aft flight deck of Atlantis all day today without a break, reading through each specific step of the checklist, helping Mike and Ron through every single task that they had to perform and making sure that they did that right and didn't leave anything out. Doug and Sandy were in the cupola on the robotic arm, driving the robotic arm to support the transfer of the pump module and the RRM, and you'll see more of that later in the presentation. So otherwise, there was some cargo transfer conducted today. Although we had most of the crew busy supporting the EVA, we were fortunate to have great support from our Russian colleagues, working with some of the spare hands we had from the shuttle crew and Satoshi Furukawa. They were able to complete almost 30 hours of transfer from the multipurpose logistics module into the space station. So we're slightly ahead on the transfer schedule, which is really good news. With the extra day that we added to the mission yesterday, we're going to be in great shape on cargo transfer. I have no concerns there. So with that, I'll hand it over to Glenda to give you some of the details of the EVA.
Hello, everyone, and thank you for coming. First of all, I just have to say, wow, this was so great. We worked so hard to get these crews ready, especially during the space shuttle training template. And this was an accelerated template. As Chris said, we all had to put in extra hours for many months to try to get this all together because the crew was on orbit. We had to pull in ground team members to help us out, more so than we ever have before. And it took a lot of people working really hard together, and it was just so good to see it all come together and all goes really so smoothly. Right before the EVA, I leaned over to my on-the-job trainer and said, I just got to say, this is so cool to finally get there and be ready for the EVA. That was quite a moment. We went out the door about 40 minutes late. Fergie and Satoshi were helping Ron and Rex get into Ron and Mike get into their suits, and Mike and Ron get into their suits while Rex was finishing up their final tool config. And then as they were working through all of that, including the aisle or in-suit light exercise pre-breathe protocol, they were making sure, very meticulously checking through all their steps, and they ended up going out the door about 40 minutes late, but we were not at all concerned about that. Chris and I had talked about that and had a good plan for managing the overall day length for the crew. And I brought some video, so let's go ahead and run that. We started out installing the new COLT tools, or the Contingency Operation LAPA tools, onto the backside of the pump module platform. Those went right into position. What a great team working together to get that designed. Those tools worked flawlessly. Pump module hung up just a little bit on the external stowage platform before we got it released. He gave it one more little try with the PGT. Bolt didn't turn at all, so he gave it a little yank, and the whole thing came loose. And there you can see it starting to move. It's about 1,500 pounds, so it takes quite a bit to move it. Here you see Ron controlling the whole thing on the robot arm, and notice he's just very slowly turning the whole thing over. It started out in one orientation, kind of a heads-up orientation, and he needed to turn it 180 degrees around so that when he got down to the payload bay, he'd be heads down in the payload bay and could install the pump module when he got down there. All of that went really smoothly. It was just like watching the training in the VR lab and in the neutral buoyancy laboratory. We were really glad to see all of that. Here you see the robotics refueling mission just about to be installed and handed off to the Dexter arm over on the lab nadir. I know that everybody at Goddard was holding their breath here, making sure that we were all sending them good wishes, and we were able to get it installed onto the Dexter just fine. Then it was off to install the MISSE, or the Materials ISS experiment, the small portion of that called the ORMATE. Took some photos of that. That's material samples that are exposed to the ram and wake of space. From there, we went on to work on the grapple fixture that had the little wire sticking out through one of the latch doors. You can see it getting cleared there and then pulled out of the way. That went just like the training. It was just like watching training video to see how well this went, just like we had planned. It doesn't always go that well, but today it sure did, and we were glad to see it. Our final task on the EVA was installing the thermal cover that Chris was talking about. Here you see it coming out of the bag. You can think of it as a great big comforter coming out of the ORU bag, or the on-orbit replacement ORU bag. Here you can see it in its final configuration, strapped down. It's got 9 Velcro straps that hold it into position. And about the time that they had it installed in this configuration, the thermal officer in the front room in the Mission Control Center stood up and turned around and said, "I can already see it starting to take effect." He could already see it in his data just that fast. So that's a very successful project. We wanted to wrap up as close to on time as possible today, and we did that. We were able to pick up the large cutter tool out of the port toolbox. We brought that inside. The Russians are going to borrow that from us on their Russian EVA that's coming up a little bit later this summer. I'm going to take just a minute to thank my team. What a great team. We had Ernie Bell on the airlock position, giving me calls on the configuration of the airlock throughout the EVA. Grant Slusser was keeping track of the EMU consumables, or the spacesuit consumables, how much oxygen we had remaining, how much power and CO2 scrubbing capability. He was assisted by Tamara York. It was great to hear all of them on the loops, and we like to hear them as little as possible, because the more we hear of them, the more problems we're having. And they got to be really quiet today, so we were glad about that. Darren Welsh was on the task console, giving me task times as we went along, pointers just in case the crew ran into trouble, keeping one finger in the contingency pages just in case they ran into trouble, and he could give me quick words to help straighten them out if required. Scott Ray was assisting him, and he actually took over and was prime for a little while. He's one of our trainers, and we allowed him to what we call hot OJT, or hot on-the-job training, for a few minutes in the EVA while we installed the PMA-3 cover. We kind of gave that to him as a prime task to get him ready for certification on International Space Station spacewalks in the future. They were also assisted by Charles Goff, who was also helping them keep track of tools, tethers, watching what was going on during the EVA, making sure that while we were listening, he was watching on the downlink. While we were taking notes and had our eyes off of the TV for a minute, he was the one watching, keeping us straight on all the other calls. Have to say, there was a little poignant moment while Ron was finishing up down in the payload bay. Those words about it being the last EVA in the shuttle payload bay were pretty touching to all of us. Of course, we're technical people and we keep our heads in the game in real time, but there wasn't any one of us that didn't have a little bit of a catch in our throat as we went on with the rest of the EVA. I also wanted to thank all the people out at the Neutral Buoyancy Laboratory. They've been great throughout the shuttle program. Prior to that, we had the WETF, or Weightless Environment Training Facility at Johnson. A lot of those folks started at the WEDF and moved over to the MBL and have supported the shuttle program throughout, and wanted to thank them for doing such a phenomenal job. We've now come down to the point where we can watch a task in the NBL and compare it to on-orbit times and know just about exactly how much time it's going to take in space based on adjustment factors, knowing the experience level of the crew, the complexity of the task, the history of the various tools and products involved. I'm not saying it's all science. Took some luck today, too, to hit it on the numbers, but we certainly did, and it's a good validation of all the work that folks prior to this have put in to help us out with all of our planning tools. So a lot of thanks to all the EVA officers that have gone before me and all the hard work that they've done on the Space Shuttle program. We're not done, though. We still have an International Space Station to maintain, and we're preparing for all of that. And then we're getting ready to go explore the universe as well, and looking forward to that as well. That's all I have, and I know Ben wants to say some special words about the robotics refueling mission.
I would also like to talk about the future. Thank you, Glenda, because this is not the end, this is the beginning. So first off, let me start off by saying that the words cannot express how excited, proud, and humbled I am to be part of this, this historic mission. It truly is a great day. I speak for the entire Satellite Servicing Capabilities Office at Goddard when I give my thanks. First to the STS-135 team. It's a very large team at Kennedy Space Center. We get excellent support there whenever Goddard processes a payload through the shuttle program. We have had fantastic support with all the Hubble servicing missions, and now with RRM. Cannot say enough about our good friends down in Florida. From the payloads office to the 4 EVA crew members who gave us a fantastic ride to the International Space Station a couple days ago. And speaking of the International Space Station, I would now like to thank the 2 EVA crew members, Ron and Mike, for excellent work today in getting us from the shuttle on to station. They did a fantastic job. Thank you, Glenda, for making that happen. I think it's a testament to the ability for the various centers at Goddard to work as a unified agency, what you saw today. The ISS Payloads Office at both Johnson and at Marshall. I don't think it's a stretch to say that RRM is the most complicated payload experiment to sit on ISS and be poised for future operations. And we could not have gotten to where we are today without the excellent support from the payloads offices at both Johnson and at Marshall. Canadian Space Agency, they are trusted friends with the ISS program, and they again came through with excellent form today with the Canadarm2, transferring us, helping Mike and Ron transfer us from the shuttle to ISS. And in the future, we will be using their Dexter robot, their 2-armed dexterous robot named Dexter, to perform operations with RRM module. So thank you to the Canadian Space Agency. And lastly, my thanks to the robotics refueling mission team at Goddard. My team back at Goddard is a great team from top to the bottom, from design, development, configuration management, the electrical team, the mechanical team, the thermal team, contamination. It's a large team, and they all put in incredibly long hours. Essentially, nobody on my team had a Christmas or a New Year this year as we were frantically assembling and testing the flight hardware to make the launch schedule, because we did not want to miss the opportunity to ride the shuttle one last time. So here we are. RRM, the robotic refueling mission, is now poised on ISS, which is a fantastic on-orbit laboratory. We could not conceivably envision getting a payload to orbit from concept to capture on orbit in 18 months without having ISS, that fantastic infrastructure already in place. power, communication, thermal, 3-axis stabilized, telemetry to the ground, commands up, and a 2-armed dexterous robot waiting for action. Without all those capabilities, we would not have been able to get RRM to orbit as quickly as we did. So we are looking forward to our future operations on such an incredible orbiting laboratory. So, not to be overly dramatic, but what we hope to do with RRM is to demonstrate the tools, the technology, and the techniques for on-orbit servicing. So what is on-orbit servicing? What can it do for an agency? Well, with on-orbit servicing, a satellite that's out of fuel does not necessarily have to be discarded, thrown away. With on-orbit servicing, a brand new satellite just delivered to orbit with a deployment failure does not necessarily have to be hobbled for the remainder of its operational life, but rather could be brought back to fully operational status. So, servicing is not a panacea. It's not magical. It will not solve all of our problems. But if done properly, it can be a useful tool in the agency's toolbox. It can be another arrow, another set of options in the agency's quiver should they want to use it for repair, refueling, or on-orbit construction. So thank you for your attention, and back to you, Mike.
Okay. Thanks very much for the opening statements. We'll move first to questions here in Houston, and then I understand we have a reporter on the phone bridge. So any questions, Gina? Please, sorry about the microphone, but if you'll just step up to it.
Gina Sinceri, ABC News. It sounds like the spacewalkers were in a particularly good mood today. I thought I heard them trying to whistle. They were making jokes. Tell me a little bit about their attitude out on the spacewalk.
Oh, the whistling thing is kind of fun because, among all the spacewalkers, they all talk about it. Can you really whistle? Because of the lower pressure in the suit, less molecules in the air, so you really have to take a deep breath and blow hard to whistle. And so they all try it. Well, I won't say they all try it, but Mike definitely wanted to try it, and you could hear him trying to give it a go. He got a little whistle out at the beginning, and I think that's just a little fun for them. You need a little something to break the tension too, because you're going out. You've got 6.5 hours ahead of you, and there's not a lunch break. So it's a lot to be thinking about as you head out the door. As we sat down at our console too. So it's fun to hear that, and that kind of puts us all in a good mood for the day. Ron was also in a good mood. Those two like to work together. They've done 3 EVAs in the past, worked that whole mission together, and did as much of their training together as they could. They were on separate rotations in the training schedule, but always fun to see them working together.
Rob?
Robert Perlman with CollectSpace.com. I think I heard that the next U.S.-based EVA is about a year away, if that's correct. So are there any special things that need to be done with the Quest airlock at the close of this EVA to maintain it for a year? I mean, is there anything can it sit dormant for a year and then just be powered back on when needed?
We've got a regular maintenance schedule. Each piece of the equipment has its own maintenance requirements. So at a certain rotation time, we've got to get the suits out, hook them up to the surface and cooling umbilicals, and start the pumps on them, on the water pumps, to pump cooling fluid through the lines. It's water that runs through the lines, and we re-iodinate it. There's an ion filter that we use to clear out any particulate matter that might have grown in the line when it wasn't being used, as well as adding iodine to keep it, and a separate filter that adds iodine in to keep anything from growing. So we do that on a regular basis. We scrub the suits within a certain amount of time right after we use them. So in the next couple of weeks, you'll be hearing us doing some what we call loop scrub. It scrubs both the suit itself and the cooling lines going to it. So that's a regular maintenance thing. There are also things that are as simple as the positive pressure relief valve that would provide for keeping the suit from over-pressurizing. It has to be able to crack and open up if the suit pressure got too high. And in order to make sure that that does indeed open and reseat, once a year we've got to get a little poppet keeper out and depress that. So some things really simple like that, and other things fairly complex like the loop scrubs. There are certain, in order to maintain the battery charging capability, we've got to occasionally get out the batteries and do maintenance on those, which involve charging them up and then discharging them again to make sure those are in a good configuration. So a lot of little requirements on all the various hardware. We'll have operations going on every couple weeks. We'll be back in the control room doing something, and that'll help keep our team fresh as well.
Thank you, Mark Carreau for Aviation Week, and mine's for Mr. Reed. When would you expect to do some work with the refueling experiment, and what would be some of the first things that you would do, and then what would sort of happen after that?
Great question. So the first thing we're going to do with the RRM module is transfer it from its temporary location where it's stored now on EOTP and move it over to ELC4. That will be a permanent home for operations on the Express Logistics Carrier 4. Once there, we will conduct vision experiments. Future robotic activity, whether on space station, a free-flying servicing spacecraft, all are going to involve some form of machine vision algorithms, right? The ability for natural feature detection, edge detection, the ability for these computer algorithms to sense features automatically. It's nearly impossible to replicate the harsh on-orbit lighting of space on the ground. So we're going to take advantage of the early time of our RRM on orbit to conduct these non-contact experiments. After that, we will then get into the contact, and that's where we will use the Dexter robot to access a panel that's on the top of our RRM. So I have a model here of our RRM, and this is how it will sit on ELC4. On the top, we have this panel here. So our first set of operations will take the end of the Dexter robot arm. It will come over and it will pick up our very first tool, which will be the wire cutter tool. And see if I can do this without breaking the model on live TV. So the wire cutter tool comes out, and guess what the wire cutter tool will do? Cut wire. That's right. So we have safety wire on these valves. What you have here is a panel that is very similar to panels on orbit right now on satellites. To access some of these interfaces, we first need to cut safety wire before we can unscrew a cap. So the wire cutter tool will come in. It will be flown via the robo operator from here at Johnson Space Center. They will be using onboard cameras located here and here that are pointing at the business end of the tool. And so that robo flyer will come in, hook safety wire, command the Dexter robot's torquer drive to turn on, and that will chop the wire in half. So that's just one example of many, many more. You see the outside of the module is covered with many satellite interfaces. Basically, half of what you see are the tools to perform the operations, and the other half of what you see, items here, on the front, and on our task boards on the sides, those are all interfaces that are presently on orbit on legacy satellites. So we have mock satellite interfaces and the tools to robotically access them. So these operations will take place over the next 2 years.
Philip Sloss with NASASpaceflight.com. Just a question on the grapple fixture where you got the grounding wire out of there. It looked like one of the latch doors stuck open before he left the work site, and I know that on the air to ground they said that that was okay, but was that anticipated ahead of time? And I mean, why is that okay, I guess is the other question.
Okay, well, we have seen it before, and we definitely anticipated it here. When this grapple fixture was inside prior to the time that was taken out and installed, the crew members were making a good inspection of it, and at that time they happened to notice that one of the doors was hanging up like that, and they were concerned about that, so they had sent us some downlink video of it, which was interesting because we pulled that video out on the last mission during the STS-134 mission to see if this wire was visible at that time. And interestingly enough, it wasn't. Somehow between that time when that video was taken, maybe I think that was last September or October, sometime between then and the STS-134 mission, that wire managed to find its way out. You asked about the door, though, and during that time he was seeing that the door was sticking, and that's why he sent us the video down. And we had all the folks up in Canada go take a look at that, make sure that that was okay, and they think that they have seen it a number of times before. It eventually shakes loose, so we're not at all concerned about it.
Thanks. And then for Mr. Reed, what is there a sort of a set period of time that you're going to be running all of these tests, and then long term, is there any thought about doing a second generation module that might go up?
Again, great question. So we will be using the Dexter robot. The Dexter robot is held at the end of Canadarm2, the 55-foot SSRMS. Space station is a busy place. It is a buzzing hub of activity with incoming vehicles, visiting vehicles. The Canadarm2 and Dexter are needed for some of those operations. So when the robotic facilities are busy, we stand down. When they are available, we will be scheduled in and we will conduct our operations. So I cannot tell you exactly what days in the next 2 years our operations will take place. That's going to depend on a lot of factors outside of our control. We anticipate roughly about 2 years to finish off all the various tasks we have on the module. Each individual task we anticipate running for in the neighborhood of 6 to 8 hours a day. If we need to go longer, the robo-operators here at JSC have eagerly volunteered to work extra hours. We think this is going to be fun for them. Not that moving large ORUs around isn't also fun, but we think this will be a different kind of fun to be able to use Dexter to perform these types of operations. And you asked about follow-on. We built our module with future expansion in mind. So on top of the first on the side, we have 2 task boards. So one task board is here, this footprint, and with 3 mounting points. The lower task board, same footprint, it's 3 mounting points here, here, and here. Well, on top, we built the possibility for a future task board. So you see there are 3 receptacles with no task board around it. So we gave ourselves the option that if we get in orbit and we realize, gosh, it sure would have been great if we'd flown this other doohickey that we didn't think about at the time, or if another customer comes to us with issues with their satellite in space and says, hey, could you fly a zipper? I want to see if I can unzip a zipper with a robot, or whatever the case may be. Well, we have the option here to mount a future task board.
Denise Chow at space.com. Question for Chris or Glenda, I'm not actually sure. With this being the last spacewalk of the shuttle era, what exactly does that mean for future space station EVAs? Does that mean that astronauts are going to have to get more extensive training in robotics because there are going to be fewer hands on deck, or are there going to be any changes at all?
Yeah, this spacewalk really was a bridge between the past and the future, because it was part shuttle-based and part station-based. The payload, the RRM payload came up on the shuttle. The pump module is going back home on the shuttle. And we had shuttle crew members supporting the spacewalk through robotics and through the inside the vehicle with the choreographing. But it also shows you the way of the future, because our space station crew performed the spacewalk. That is how all our future spacewalks will be performed. Glenda mentioned how we always keep our airlock on the space station ready to go. That's to support not only the planned spacewalks, but also contingencies. I mentioned how the pump module failed last summer, the one that we brought back today, or put in the payload bay today. that is an example of one of our, currently we have about 11 on the list of EVAs that we need to be ready to execute within about a 2-week time frame. There are, again, other contingency cases that would require a short turnaround EVA in order to assure the survival of the space station. So every space station crew that flies receives training in those contingency EVAs so that they're ready to go if they're called to do so, and as well as any planned EVAs. For example, if we end up adding additional components to RRM, as just one example, or other tasks that will be required, then we'll train crews specifically for those tasks. We'll train them similarly to what we did for Mike and for Ron for this EVA, extensive training in our neutral buoyancy facility here in Houston, as well as after they get on orbit. It may have been a couple months since the last time they practiced it. They'll get additionally extensive training on orbit study and preparation before they go out the door and actually do the spacewalk.
Any further questions here in Houston? If not, Marcia Dunn, are you on the phone?
Yes, I'm here. Thank you. I have a couple questions for Glenda. I was wondering, when exactly is the next spacewalk by American astronauts at the space station?
I don't have the exact date with me, but it has been moving around a little bit. We'll get the current planned date. It is next fall, in fall of 2012, but I can't get you the exact date. We're pretty far out from that, so I would anticipate that it could very easily move a little bit, a month or two, maybe even. Just depends on some of the visiting vehicle traffic that we were hearing about. There's a lot going on Space Station right now, so we'll have to fit that EVA in between all the other work.
Thank you. That's close enough. And I was wondering, as the pump was going into the payload bay, there seemed to be a brief hubbub up there about a strap that may have gotten away. I couldn't tell if it was ascertained whether a strap did float away or not. Do you have any detail?
Some of the people on the team, like I said, everybody's got a job, and we've got a couple of people that are just supposed to be watching for things like that. There was what looked like a short strap, maybe one of the strap handholds from the pump module multi-layer installation that might have come free. At the time that it came loose, Mike was maneuvering around in the payload bay, around the back portion of the payload bay, trying to secure some of that multi-layer insulation that had come up on the top of the pump module. It was sometime during that time frame that the guys saw it float away. It was about an inch wide and about 6 inches long. Looked like it was one of the cloth straps. Those deorbit really quickly. Then we passed on the information to our topo folks to make sure that there wasn't any vehicle concerns with that. And that's all I have on it right now. We may learn more after we get the pump module back and look at the insulation on it.
So it sounds like then that the strap did get loose, did get away?
It's possible. I don't know exactly what it was. That multi-layer insulation that's on the pump module has several handholds. They're really just meant to help you maneuver the multi-layer insulation around. They're not really meant to be used as translation aid. It is possible that if he had a tether hooked on one of those, they might have come loose. They're not designed to take a lot of loads. They're just meant to help you manipulate the MLI. I don't really want to speculate on it anymore. It could have been any number of things. Again, we aren't concerned about it being a recontact issue or anything like that.
That's fine. Thank you.
Okay. Any further questions here in Houston? If not, we'll wrap this briefing up. Thank you very much for coming. Looking forward on NASA TV's schedule. Coming up at 6 o'clock Central, 7 Eastern, we'll have today's video file. And the crew, of course, is getting ready to go to bed right now on both sides of the station, the shuttle. And then we'll be having the International Space Station Flight Director update with Courtney McMillan at 11:45 Central, 12:45 Eastern. And with that, we'll close this briefing out. Thank you for coming.
Hi, I'm Glenda Brown. We're the EVA team for the final shuttle mission, and you're watching NASA TV.